This is Hack-a-Gnome, one of the challenges in the Act 3 of the Holiday Hack Challenge 2025 game. And this one, I was putting this aside for a very long time. I think I solved all the other challenges except the last one before attempting this one. And the only reason I solved this one before the last, before unlocking the final challenge, was that I wasn't sure how the game mechanics worked if I'm not leaving this one to the last one. This is not because it's a bad challenge. It's actually a very good one. It's just that it has difficulty level of 3 snowflakes. And for me, this is closer to 5. Not exactly 5 because we get a lot of good hints, but it's close. And we also have some additional things that shouldn't be there, but it's there because it's a CDF game. I'll mention these, but it's at least for me a 4 out of 5. And even with the help of Claude, which wrote 2 of the scripts for this, I spent hours and hours and hours on this. And even the last part, I failed once and I had to reset the factory because, yeah, I'm not really good at those crate pushing games, and that's actually what you have to play, or you can automate that one. But enough talking, let's get started because we have to cover a lot of things here. So right off the bat, the location for the challenge is in the data center, and normally I would just go there and just tell you that you either switch to CDF mode and you can access the challenge, or you figure out how to get there. But there is a challenge in Act 3 which requires you to get to the data center and navigate there. And it's a bit tricky. So we haven't been to the data center before. One challenge that was outside of the data center, we just talk directly the NPC and access the terminal that way. So the data center entrance is kind of tricky. And if you go to the corner of the data center near the Grand Hotel and the park and rotate the view, I'm not really sure it's only me, but this fence, it does not render. And the gnomes are not helping because they can just float through it. But if you look carefully as I'm rotating it, there is a hole in the fence. And you can also use, see, there's the hole. You can also use the trick with the WebSocket communication and just find where's the entrance. If you don't know how to do that, check out the first video of this series under orientation. I explain how the game mechanics works and how you can exploit it. I know a lot of people don't like the fact that I have a long video in the orientation section, but that's the reason, because if someone never played a Holiday Hack Challenge, they don't know how the game mechanics works. And for some of the bonus challenges, for example, or some of the challenges, that's actually what you need to leverage, or you should leverage. There is an easier way, of course, to get inside the data center if you want to, and that is, again, kind of using the game mechanics. So I'm going to go to the other corner of the data center, and there's the Easter egg puppy there. Oh, no, don't go that far. The character is now self-driving, and you can see in front of the data center entrance there's this glowing yellow light, and your cursor changes. If you just click on the entrance, your character will use a path determined by some probably very simple algorithm to go and find the entrance automatically. Now this is not necessarily the shortest path, but I think it's pretty close to it. And then you can enter into the data center. Another thing that you probably want to use is, aside from rotation, is the fact that you can make your view smaller. And in this case, there's no point zooming out, but at least it's easier to find the glowing point. There we go. But here we are in the complete dark. And later we are going to navigate these rooms here. These are part of one of the challenges here in Act 3. But we can easily find this corridor here. And you can look up the map again in the WebSocket communication. We will do that when we solve the challenge involving these strange rooms around. That's basically the easiest way how you can get to the, let's reset this, get to the location on to the GNOME factory. Oops, I was just surprised that there's also terming GNOME here. It's gonna pick up the little gnomes every now and then. So Chris Davis is going to give us the briefing for this not so easy challenge. There's a lot of communication here, but the important part is to extract the hints here. And here you really need to concentrate on those hints. So let's get the first one. The first hint is telling you about some type of database under the GNOME control factory that it's using. And it has like some documentation on the default document types and properties. These are very, very important. This information could be could help you get a list of common English first names try for your attack. So it is talking about a database and finding default document types and properties, and then trying first names for an attack. So one part is about the SQL injection, or well, no SQL injection, because we will see that the database is a special one, and some user enumeration. That's just the first hint. So let's take the other hints as well. Hint. And this one here, I'm not sure if it's really visible, but it talks about CANBUS controls and controlling the smart GNOME, and the fact that they had problems with the prototype and pollution. So these are big hints. One of the things that we need to exploit here is a prototype pollution vulnerability on the server side. So we'll see that the server side is running Node.js, and we have to exploit this vulnerability there. Okay, let's get another hint. And this one is talking about the CANBUS client.py file. And that's why I'm saying that this is probably not a 5 snowflake challenge, but at least a 4, because we get a lot of information here in the hints, and also there are additional programs with special features that normally shouldn't be there. Basically, one of the things that I tried and worked out of the box was using Netcat to get a shell. Usually the -e option is not compiled in the package versions of Netcat, but this system is going to be an exception of that, and that makes it so much easier. There are alternative ways, of course, but that was kind of nice. Okay, so we have the CANBUS client Python script here. And we can get one more hint. I can't remember how many hints we have, but this one has quite a lot. And then this one is, talks about the backend statistics page. This is related to the prototype pollution vulnerability, and also talking about the CANBUS controls not being hooked up necessarily correctly. We'll see all of these later. And there is a 5th hint, apparently. It tells you that sometimes it's just better to use something like burpsuit or zap to reveal an error message that can be useful. And let's see if there's a 6th hint. I think this one has the most number of hints. It talks about maybe you should use the isDefined attribute for the database to figure out the common attribute names for the target user's entity. And then depending on the hash type, see if you find an online cracking station. This is obviously a reference to CrackStation. So CrackStation is a very well-known site, and you will find actually, like, I already have it bookmarked here. So CrackStation is where you potentially will be able to look up hashes, see if anyone cracked those hashes. that's going to be the case. You want to follow this one. I haven't even searched online because when you see like cracking station and it's bolded, I'm like, okay, that's crack station. So there's some CTFE references here, but that doesn't mean that this is an unrealistic CTF challenge here. Actually, it's a really good one. I did struggle the most with this one, and probably the one that is going to be unlocked after we finish all the challenges. So these two were, for me, where I spent most of my time, like, again, hours, but this one has so many convenience things and hints that it is easier to solve. Again, I still don't think that this is 3 snowflakes, but other than that, I was really surprised how well the difficulty levels were estimated this year. Usually it's all over the place, but I tend to agree with most of these. Probably this one and JVKS spoofing one, I would bump it, and maybe the last two I would like probably decrease it, and you will see why. That's not a fault of these are tough challenges. It's just that with some of the LLM tools now out there that can generate code, it becomes really easy. Actually, the on the wire one, I think it's closer to like a 1 than a 4 difficulty level one, and Frisky is probably also closer to, yeah, that's also closer to like a 2 tops, again because of the coding tools. Okay, I'll just get rid of the notifications because they annoy me. And the interface that we are dealing with is this login screen. Now, if someone gives you a login screen during a web application penetration test, you know that you're going to have a hard time here. So you should always try the default admin. Worked so many times in my career, so I'm always doing an admin. You can also look up, default credentials. You need to choose a username. Now, when you choose a username and try to choose a password, it is giving you a message saying username is available. That is a big hint, especially combining it with the hints that we got, that there is potentially a user enumeration issue here. All right, so can we actually register a user? No, we cannot. Registration is currently closed, so we don't have credentials and we're not able to create a new user account, but there is user enumeration. That's good news. Okay, I am going to switch accounts here. I have this other account and I want to go to the I can't remember if I need to check how the login works, so let me just look at my notes. Yeah, we can, sure, why not? Try out the authentication here. Let me just get rid of most of the stuff here that we don't really need. Actually, I'm going to just probably clear the history. It's the easiest. And then click again this page. It loads again. You can force reload it. There we go. And there is the login page here. So there we go. There's some jQuery script.js, which does not have anything interesting, so you can check this one, but there's really not much here. It's just submitting our attempts here for a user enumeration. So let me show you admin here. Send it in. We'll generate this post request, sending the username and password. So nothing really special about this one. These are just cookies related to the challenge configuration. And for the access, let's put there David, and then we should see a query generated here. Not sure why I'm only seeing the response. There we go. That was strange. So you can see that there is this /user available username, And there's also this ID field. We also have Google Analytics cookies and connect SID. But this is giving us back the check result to see if whether the username was available or not. And we can try user enumeration here. What I did, and it was taking too long. So initially, I went for SecList. You should always go for SecList. It's a really good collection of various lists for enumeration. There's some passwords is there, but that's not the main reason why I like it. It's more for doing different kind of enumerations, brute forcing of like directories and file names. And they also have things like payloads, but under usernames, there's the names.txt. This is fairly long, so I think it has 4,000. Oh no, even way more than that. So a lot of entries. And when I tried working on this challenge, the site was fairly slow. And it was also sometimes like doing timeouts for me. And I just gave up on this because this is also a database that is hosted by a provider. I don't want to spoil the surprise here. You also going to be rate limited by that provider. So there are shorter lists, and I went for the ones here instead. Male names USA and female names USA top 1,000. So this is just 1,000 names. This also takes forever. And I also had to convert this to lowercase. So what we're going to do is a much shorter list, but basically you can go, let's take this to repeater first. You can get rid of some of the parameters that are not going to matter for us. This is actually mentioned in the hint, and use just this request basically, and it works pretty well. And I'm going to send this one now to intruder. And I can configure a payload on this name field here, and then I can add my list. I'm going to use a very short list here, paste it in. Now, if you need to do some payload processing, because let me show you what I had to do here, because you have like a list that looks like this, and it's all uppercase. There's payload processing, and you can do modify case to lowercase, and then you will have a list that is lowercase only. Oh, there's only a few. Just remove a couple to show you how that looks like. I'm also going to remove David and Rich. No, not all of them. Okay, let me just paste in like 3. Not this one, sorry. Not this one. Okay, I just want to start the attack. Ensure that it's actually converting all of these to lowercase, and we see that available true, meaning, so when we get available true, that means that it's not used by anyone. It's not a valid existing user. Okay, I'm going to use now a short list. So I'll remove the processing. I'm going to clear this one, and I'm going to paste in Alice, Bob, Bruce, Harold, and Tom. Okay, just 5 usernames. Obviously, Bruce and Harold is the one that yields with a success. Now, these are included in this list, but it takes forever to get there. And you might also see like timeouts. So we're not going to, where's Harold? There we go. So this is a good list, and it works. It just takes a lot of time, and I don't want to waste time on this. So let's just start the attack. And you're going to see that the length of the responses is all over the place, but we can look at available true for Alice. Bob, Bruce says false. That means it's taken. Harold is also false, and Tom is true. So this is probably the easiest way to do enumeration. I'm not sure if I keep on like spamming the discard. So we had Bruce and Harold as a result. Maybe there's more. I don't know. For the female names, the top 1,000 list didn't yield any results for me. I was also Again, struggling to get this one respond me faster. Probably people were bashing on it heavily in the past couple of days. And eventually I got like a timeout error message that revealed immediately the database type. But we can also try various characters to kind of verify if there is any sort of vulnerability here. And you can do this via scanning. That didn't really give me any results, but I took this list of all the various characters because I wanted to know, like, are there any like forbidden or filtered characters here. I'm going to use the same approach in another challenge, and I always find this one a useful approach. So this is just a list because I'm not sure if we have this kind of list in Burp Suite. It's just a list of all the printable characters. And then we're going back to intruder, and here I'm going to remove my username, going to clear the list and paste in the list. So this is numbers, upper lowercase, and some of the special characters. When we launch the attack, I'm going to change the status code for this one. Hopefully, no, but the length. The length should stick out. No. But it's interesting. What kind of response is this? So, no. Oh, now we're seeing the timeouts, I think. That is becoming suspicious. Okay. Now it's slowing down us. So this is the backend doing it. Didn't really expect that it's going to hit with the throttling. Wonder what's the length difference here. Interesting. The connect SID is longer than the other ones here. So again, this is just to enumerate what characters are allowed. Here, I'm not really sure if there's anything surprising. Oh, that's excellent. Look at the response times. Oh yeah, but it's just the time, not the size, unfortunately. Let me see. I know some of the characters. There's a longer one here, so we can order by length. Gonna find out if we reached any sort of error conditions here. So there is one error for the slash. This is your encoded. Actually, I think it's backslash, right? And also the single quote. Now, there have been in the hints a lot of references to databases and enumeration and all that. So this is already pointing towards the fact that there might be SQL injection. I tried the login form. There's nothing in there. This is the only endpoint that I could find. So I started like looking for SQL injection. And apparently these, and also the percentage character, results in these error messages. Microsoft Azure Documents Common. So we can already like figure out from this a bit the database system. I also want to show you this error message here. Just gonna paste it in. So this was the result of me trying to do enumeration and eventually having this timeout here. Error code by checking username service currently unavailable. More info, CosmosDB. So this one is a big giveaway. This was much easier to determine the type of database backend, right? It says it's CosmosDB. So CosmosDB is the backend, and this is a NoSQL database service available in Azure. So that's why we see Microsoft Azure Documents Common referred here. And if you look up the error message here, you can also, from this error message, figure out that we're talking about CosmosDB. The fact that the payload backslash and double quote is generating this error message kind of makes me feel that in the query itself, there is probably when we drop in the double quote, an unclosed double quote expression, and that's why it's generating an error message. The percentage symbol says URI malformed. Again, percentage is usually going to be a substitute for a character in database systems. So these are all good indicators that there might be SQL injection available. Let's try to explore that one next. We already have valid usernames. For example, Bruce. I'm gonna use Bruce for most of the walkthrough here. And Bruce has a response available false because this name is taken. So we can test for SQL injection, a bunch of things. The idea is that if this is a blind SQL injection, then Bruce is a valid user. And if my second expression here is also true, we still should get available false. And we do. However, because this is an AND statement, if any side of the AND statement is false, then this should evaluate, like where we're injecting this payload, should evaluate to true. And that is exactly what we're getting. So the expression should evaluate to false, and then it means that the returned value here is available true because it's about whether the username exists in the database or not. I actually found this one confusing, so I'm going to do a negation of this so that every time our statement here on the right-hand side of the logical operator is true, you're going to get back true, and then we can get back false for the other cases. I know this was not probably the best explanation, but what I'm trying to explain here is this. So instead of just a simple AND, we're going to say AND not, and a lot of tools, by the way, do this. So AND not 1 equals 1 means that this will be a statement that is false, even though Bruce exists, to get available true. And if I make this statement false, so this whole thing evaluates then to false and returns an empty data set, then we get back available false. Maybe it's just for my head, not really sure, but this makes it easier for me to think about the injection, so I can just, I don't have to negate the expression. Now, of course, we can also do the same thing with a non-existing user and, I don't know, do something like Bob. But we need to change this to or, and I don't think we can negate this. So Bob or 1 equals 2 is going to be a false. So this returns true, I think. Yeah. And Bob or 1 equals 1 is going to be a false, right? Because this evaluates to true, and that means that the check whether something was returned from the database or not is going to be a true statement that is on the application logic side, means that the user account is taken, so it's not available. Yeah, this whole availability check brings in this negation, extra negation, and the whole thing. It just makes it a lot more painful. So basically, that was the idea. I'm just looking at what kind of stuff am I looking here. Oh yeah, okay, I understand. So we understand here that there is a SQL injection. Now I went for this type of expression. And then the task was to write a script. And I did not write the script. I asked Claude to write me the script. And it did. There is a couple of things that I asked, but this is the first attempt. So basically, I fed in all the hints. Let's see what I pasted here. Yeah, basically I just copied out the conversation, the name of the challenge and the description of the challenge and the hints that we extracted. Then I pasted in some of the request responses here, and all the checks that we went through. So explaining basically like the characters that causing error messages, and yeah, the error message itself. And I thought that I also had some SQL injection related stuff here, but maybe I pasted in later. I'm not sure. Or maybe I just forgot to do that. Okay, that's strange. Could have been here as well. Doesn't really matter. So the point is, this took seconds, maybe. I mean, assembling the prompt took a bit more, but basically the same amount of time that we took to kind of go through this and explain this in the video. So I asked Claude to create me a script for me that does this CosmosDB SQL injection using some of the hints, and this resulted in this script that has some of the built-in CosmosDB system properties and some common property names, so things like password hash, password underscore hash, hash, PVD, and so on. So you get the idea. So secret, that's kind of dumb in my opinion, but who knows? None of these are actually in there, except the username, I think. But the password hash field is actually not called any of these. So initially I went with just the defaults, but I already asked it to have the option to feed in a word list. Now, normally you could also do a blind injection and try to get these ones letter by letter. But because the isDefined function was referred in the hints, there should be somewhere, is defined. There we go. I asked Claude to use this method for the enumeration of the properties. And I can now go and show you what the script actually looks like when we're executing it. Now, for the properties, again, I went back to seclist and I used the web content one here under the, what is it? Discover web content. There's some good names for variables. I used the common dictionary here. I also wanted to use the burp parameter names one because that's also a pretty good one. But that is a bit larger than the common one. I did run the common one and it came back with some, well, results. But it took much longer. So we're going to feed in a shorter list, like a significantly shorter list compared to what I was using. And what we're going to do is just a couple quick executions. So the script can test for the SQL injection with an existing username. So this is just doing the same test basically. And it says, yay, it's working correctly. And then we have the option to do quick enumeration, or one that is kind of combining that short list and a dictionary. And we're going to use this one. The short list here is, do I have it here? Yes. It's just 10 of these because I know already which one is going to be the winner from this list that we still need. So username, we had that one in the quick enumeration one, and actually digest is the name of the other one. This is defined in the common list as well. Again, it just takes forever to execute it. This also generates a lot of error messages, so I had to go back and kind of make Claude correct it. Let me show you the actual execution looks like with a bunch of error messages, but I'm feeding in the common list here. You get the idea. So this is just going to be a fast one, and because it was kind of responding slowly to me, I decided to add a delay between requests, and this is a configurable parameter. Again, I didn't write the script, it was Claude writing this, and it's using the isDefined attribute in the database to check if any of these properties exist. Based on the documentation, it uses the CosmosDB system properties. So there's ID underscore RID underscore self and so on. And it finds username plus also digest from the word list that we fed in. So that is the idea, basically writing a script or have an LLM tool writing the script for you to then do the enumeration for the properties. And this is really just based on the hints using the isDefined. Again, for checking the properties. And there's also the word list based one. So this part, the enumerate properties, is just doing this. This is just checking the property names based on this list, checking the injection. So that was the test functionality. And then getting the string length and extract string value is for the full-blown enumeration, blind enumeration. And there's also an extracting the hash one, which is just focusing on hex values, because if it's something like a SHA-1 hash or MD5 hash, those are the only characters we're going to have. So this is not something that I actually asked from Claude to include. It just did it. And this is actually pretty good because it speeds up significantly the blind injection. So once we have the property names, the hash, oh, sorry, that's CLS, not Control L. It's a Windows terminal now. We can execute it, different parameters, and -- all users is going to use the two users. These are hard-coded, so Bruce and Harold was the other one. And then we need to provide the name of the property that contains the password hash, and it's going to do this optimized blind injection. I'm going to start it and then keep on explaining it because it takes forever to get the hash values. I'm probably not even going to wait for it to succeed. I just want to see if it starts. So it determines the length of the hash first. This is pretty fast because you just basically loop through the numbers from 1 to, well, as you can see, up to 32. And then it has to go through letter by letter. Now, you see that it takes some time to find the letter A. That's because it starts from 0, 1, and so on, because these are hex values. But it's slowly and painfully extracting these values. Okay, let me show you what the execution results will look like, because I'm pretty sure it will have the same thing, but takes forever. So this is for Bruce. We have a hash, and then we also have the hash value for Harold. And that was a hint on Crack Station, so we can just take these, bring them to Crack Station, claim that we're not a robot, even though we totally are. And we have the username password combination finally. Now, if you think this was hard, wait until the next part. We still need two kind of big parts here. One is going to be the prototype pollution, and then we also need to figure out the correct command values for the CANBUS IDs. So this is already something that took me hours to get here. But I'm just, explaining this as fast as possible. So I don't know if there's any difference between the two. I checked the interfaces, they look the same. So I don't think it matters which one you pick. I was working with Bruce in this case. So going back to the login screen, it means that we can go and use Bruce and Oatmeal12 to log in. Yay! No, never save the password. You can see that we are now in the robot control for the factory. We have the statistics page. This was mentioned in the hints. And we also have the GNOME control interface. I'm just looking outside if the snow started again. Yes, it's snowing again. Awesome. And You're going to have a ton of snow this week and the next one. And I'm so glad that I don't need to actually go outside for this one. Again, sorry about that one. Just very quickly going to mute my notifications here. I forgot to do that. Sorry. Until tomorrow morning. Sure. That sounds like a good option. Okay. So we are on the interface. And if you click inside and try to, follow the controls and try to do up or down, down or up or left or right, you will see the values here saying that unknown CANBUS command. They're all incremental. This is actually something that I should have exploited in the past. So this is up, down, left, right. But the robot does not move. And on the statistics page, we cannot do much. So this is just viewing it. You can refresh it. Every now and then the values change. These are kind of random. We can see here one thing that is interesting. Let me just zoom in a bit. This is the GNOME config object. Now, it's kind of pity that we cannot resize this, but we can look at the entirety of this value by just copying it. And you can see here that there's a name for GNOME bot something something, model version, firmware version. And this is under the settings key. These are the sub keys for the settings key. Happened here. Oh, okay, I probably need to do the login again later because we need to manipulate the traffic here. I'll use the interface that has the interface that has the burp running under it. I'm just thinking how am I going to be able to then solve the challenge with this account? Probably have to do that one outside of the outside of the recording, but we can solve it with the other user account that I have here. So so this one here, this is video draft 2. So I'm also going to log in here, Bruce, and what was it? Oat meal 12, right? This is creating an account, sorry. Login. Bruce oatmeal 12. There we go. And you know what? I'm probably not even going to look at this one here. Yeah, there's no point looking at this one. We're already done with this one. This is going to be important later. Don't need the sec list. Okay, just doing some housekeeping here. All right, so the robot arrives here as well. And not that there's a huge difference, but we can observe these commands as they go. So here, let's see, this was communication to WebSocket. There's actually WebSocket communication happening. And here is the game state. And check out as I am doing the up arrow, for example. We see that there is this control signals message going on. Just try to hover over it. And this is URL encoded, of course. So we see action is moved, direction is up. And the same thing for down arrow. And so on and so forth. So there's also left and right. Hopefully I managed to hit the right keys here. Yeah, and you can see left, right. But none of these will actually move the robot, even though it comes back with success. So there's something wrong on the backend side. We cannot control the robot just yet. The other feature here that is available is we can refresh the statistics. So this just queries /stats and then returns whatever is in the statistics page. We can also see here the game config object. Now this is a big hint again. It makes it very, very obvious. Like look, there is prototype here, an object prototype, and that's probably going to be your target. But how can we actually change values here? Well, there's this update name functionality. Just do test again, and then update the name and see what is the message that is being sent. So for some reason, when I do shift, it sends the down key twice for that matter. I can see here a different message. The action is update, key is setting, subkey is name, and the value is test. And if you look at here, nothing changes. That's because we need to do a refresh and then the name changes. So these are really good indicators here that there's an object and we need to create the stats to refresh that object. So it's probably on the server side. You can check there's no game config on the client side actually. So there's nothing here on the client side. Where was the like post message? So I can go through. I'm not gonna see the game config object unless we are looking at what happened. Oh yeah, the stats. So stats does have it, but other than that, nothing else has the game control object. Just the stats, which is just written back from the server side to the client. Okay, so that is good. One of the hints was talking about prototype and pollution. So prototype pollution is a really special kind of animal, and in a nutshell, this usually happens with JavaScript when the JavaScript code modifies a JavaScript object and it does not properly sanitize the input from the user, and it probably just like takes the modified object parameter and has like maybe a for loop that updates the entire object, just goes through the parameters provided by the user and updates the object itself. This allows potentially a user to inject additional keys into that object as the object is being updated, or modify already existing keys. And these JavaScript objects have some special keys actually that can be abused, especially if it's on the server side, like with Node.js or Next.js. Okay, so how can we check this? How can we actually validate this? What I'm going to do now is attempt to add a new key. So let's take this message where we were updating this key. I'm going to send it to my repeater. And what I have is a payload that looks like this: action, update, key, setting, subkey, polluted, and so on. And I'm going to check whether I did, was it convert selection used and encode key characters? Yeah, no, this is not sufficient. So I think what I did was just basically changing this, and instead of settings, I put their name. For the subkey, instead of, no, sorry, it was still settings. For the name, for the key or subkey, I actually entered polluted, and then the value was success or something like that. And I just basically edited the already URL encoded payload here. If I hover over it, you will see that what I'm trying to do now is, instead of updating the name field, I am adding another sub key under the settings key with the value success. So what I'm hoping to see here is that with my action, and it says polluted to success was a success. If I go here now and do a refresh, I should see a new sub key appearing here if prototype pollution is in fact possible. That's exactly what happens. So this is a really good indication that there is prototype pollution here. You can try, of course, other payloads, but the the test is already successful here for adding a key. And there is, like I said, a special type of keys. And the __ proto key is the one that we're going to manipulate here. This is good old payloads, all the things. I'm going to use this portal a couple other times. This is one of my favorite collections of payloads. I'm actually obsessed with like having quick access to payloads when you need it. During pen testing, it's great to have. There's one extension in Firefox that lets you just quickly pick basically payloads. So this is another thing that you want to bookmark. I think they actually have a much nicer looking interface for the collection of payloads here. So what I ended up using was a modified version of this payload here. And in order to use this, we going to use a reverse shell. So here, this is just setting up a listener. That's not exactly how things usually work. And I'm just going to do the lazy thing and use ngrok. So ngrok is going to set up forwarding for me. I'm going to create another tab and use netcat. I think it's kind of giving it away that I use these tools kind of a lot because they're already in my history. And what I need to craft is 2 requests. So we need to add 2 keys here, client and this escape function. So this escape function is using this EJS gadgets for remote code execution. You can read here on keyboard, so payload all the things. And here you can see that under exec, we can insert here our command. So my command is going to be a reverse shell. And whenever you're using a CDF, you should always try to see if netcat is installed and the -e option is compiled with it. That was the first thing I tried and it worked, so that was great. I mean, the payload didn't work on some of the tries because I was fat fingering things, but once the payload actually worked, I got back the shell because netcat actually has the -e option on the server side, which is great because otherwise this challenge would be just annoying. But you can also use something like, something like this, right? So you can use the bash functionality and use a TCP session going back. I'm not going to attempt to try this one, but it should work the same way pretty much. Okay, so we need to use the repeater here, and I'm going to add my payload for the first key. I need to do this twice. So this first one is just going to modify the __ proto __ special key and add this client 1 value. And we're not going to be able to see any of these on the interface itself, and I need to modify my payload here. So let me see. This was my original payload that I used, and I just need to adjust this one. So you can see that I did the lazy stuff, and because it works, I'm just gonna stick to this one. I'm pretty sure the other method with the bash shell also works. This is not the hard part of this challenge. Okay, and the port number for the forwarding. So ngrok, if you're not that familiar with this, is I'm just using with the free plan, is a service where you can have systems connecting out to this special address that is defined with ngrok. And it's going to do a port forward locally to your local port. And I'm waiting with netcat for a shell that we're going to forward from the victim system here. And oh, I already did the changes. No, I didn't do the changes. So oh, I modified it here but not down here. Great. So this is actually TCP0, and then this port number. Now the good news is we only need to do this once, and even if you lose access to the shell through the refresh function, I can just call this over and over again. So the polluted prototype stays on the server side until you reboot the server, which is great for our use case. At least it's not that good for someone who has this kind of problem. So this is the actual command. We are adding this escape function key to the proto key, and we're going to spawn basically a new process and execute netcat with binsh and sending back the shell to our ngrok. All right, so when I send this, we're just going to see that it's a success, but nothing happens here. That's because we still need to update the object on the server side, and that happens when we hit the refresh button. Okay. There's some escaping that happened, but the connection is here, so I guess we're good. Let's do an ID. And we're root on that system. That's also a big convenience here. So you can see that they try to make this whole challenge a bit easier, but we are already at, how much time did it take to explain all this? So almost an hour passed, and this is still just 1/3 of the challenge because we still need to solve something. So otherwise, with privilege escalation and trying to figure out the right payload, this would have taken forever. And you see that all the values are from known lists, so there's a lot of like CTFE convenience, but this is very, very realistic. Okay, so we are root. That's awesome. Let's see where we are in the app directory. That's very good. Listing out files. We see that there's a .env file. Always very interesting. This is for the CosmosDB configuration. There's a README markdown, and there is that CANBUS client script that was referred previously in the hints, I believe. So when you look at the README, I'm gonna have to zoom out somehow. Okay, I can't. So when you look at the README file, it talks about these different CAN IDs for the CANBUS control. We also have the CANBUS client Python file. And this Python script is the one that actually executes those commands. Now, if you carefully look, the command map here is the same set of commands that we see on the interface when we try to move the robot. Now, you can scroll this screen actually. So when I hit up, it does hex 656. And that's exactly what we have here. But turns out these are not the correct commands, apparently. Okay, and last but not least, when you list out the server.js contents, you will see, can't remember exactly where it is, but I'll try to find it. There we go. So it is calling the CANBUS client. So what happens is when I press a key, like the up arrow, it passes it on with WebSocket. Actually, it generates a query, and then with the WebSocket, it sends it to the CANBUS controller Python script, and then it sends the command to the CANBUS. This is all simulated, but that's the idea. However, the commands are wrong, and they're not the right values for the CAN IDs. Now, unfortunately, we don't really have anything here at this point that can help us other than the Python script here for controlling the CANBUS and the README file. Basically, what we can do is, based on the Python script, learn how to send these commands by basically using the send command. You can reuse this, and you can essentially brute force the CANBUS IDs. Now we see that it's only 3 hex digits, and we can brute force from 000 up to, like, I don't know, FFF values. That was my idea, and it required me to write another script. So obviously I told Claude to write the script for me. Let me just see. There's some adjustments to the brute forcing here that I didn't like. And then, yeah, talking about the reverse shell. Complete the attack sequence. Here's the Python script. Help you test the prototype pollution. Okay, I think I ended up not using this one. And there's the brute force script for brute forcing the CANBUS. Now the difficulty here is, so it's basically just reusing the send command here, send cam message. They renamed it for some reason. I just told it, like, hey, here's the script. This is what I want to do. Write me another script to do the brute forcing. And what it can do is I can provide a range to the script to do the brute forcing. And the only issue that I have here is I need to transfer this script to the server. So what we're going to do here is use this very sophisticated method of catting inside a file and then making it executable. That's going to be our way to transfer this script. Basically here, I'm going to paste in the entirety of the script, making it executable. Now, fun fact, Claude, for some reason, wanted to drop this in temp, and we can totally write in the app directory as well. So I executed this command with the destination of temp / and I don't know, brute force, or what is it called? And I couldn't see it in the app folder, and I thought that it failed. So I tried multiple times, tried the base64 encoding and all that, and that just further complicates things unnecessarily. This actually works. So look at this. I'm gonna paste my clipboard, and when we do an LSLA, we have our CANBUS brute force Python script executable, all nice and hunky-dory. So again, I'm not going to go into the details of the script. It really just leverages the original Python script and does a brute force on the hex values for the CAN IDs. Now, I also wanted to test if we actually have Python free before I jump into this. And the brute forcing that I wanted to do initially was just looping through the values. And the fun fact is that this is going to generate messages for the listener that runs on the server side. And we're going to see these messages generated here. Normally it should also print it to here on the console, but it's probably not going to work. So let's start it up, and just for the kick of it, I'm going to end this one at 250. Okay, just trust me. So normally you would wait forever to have this one finish, and I just want to show you what happens when we reach around 200. I'm gonna start the script, and here we're going to see the script effect, basically already printing out the CAN IDs that we're trying here. So we're looping through, and I'm not even sure if this is correct, by the way, because we really should do... No, it's actually okay. Maybe it's the server side that is displaying it like this. So now at 100, looping through, and what will happen at 200, hex 200, is we will see messages pausing, and the robot moves, I think moves down or something like that. Almost there. Let's see, 1D, E, F, watch it. See, it moved down. And then nothing else happened, but this is a good indicator. So I'm doing it this way because then I don't have to kill the script over and over again. So we know that something around 200 happens. So I'm going to do another round. This time really owning on the 200 hex values. And I'm increasing the delay to 2 seconds here, so hopefully we'll be able to see what's going on. So we are at 1FC, 1FD, E, FF, 200 moves up the robot. Then the robot moves down, left, right. Okay, this is already, and then it's going to go up to 210. Okay, that's the last one of it. Oh no, sorry. We still need to wait until it reaches 10. F and 210. Okay, so if we really want to map things out, I could increase the delay, but basically, if you increase the delay to 5, you can map out with this script something like this. So the up command is 201, 202 is down, 203 is left, and 204 is right. However, these are not the commands, of course, in the Python script that controls the robot. So the problem is that we need to patch the... Oh, that's not exactly what I wanted. Okay, cat, CANBUS client, copy, paste selection. Okay. Oh, okay. Apparently this broke the netcat command, but we're not. This is actually good for the demonstration. Not sure why it's still moving stuff here, but oh, I can close this one. But when we do a refresh and we have our listener up and running, we get back the connection. So I wonder if anything here is still running. Let me just do a very quick yes, AUX. No. NSH is us. Okay, this looks pretty good. So what we need to do is patch the CANBUS client Pi script. And what we need to change is just this part here. Again, probably the easiest way to do this is replacing the script or something like that. But for me, the easiest way to do this and achieve this was to run this sed command. Let me just see if that actually fits here. Yeah. So this one replaces the values to the appropriate values. We can verify this if we like. I'm going to do a grep here. Inside, now we have the values changed. So now for the grand finale. This means that hopefully I'm going to reset the factory just in case. Because I'm not sure if all the crates were moved to the right direction. But since now the Python script is fixed, if I hit down arrow, the robot moves down. If I hit the up arrow, the robot moves up. I can control now the robot. And normally I think what you should do is probably figure out the path, because this is really this crate pushing game here. And if you push 2 crates on top of each other, you will not be able to move it. So when I hit like the down arrow now, it doesn't move the crates and you can actually lock yourself in. So yeah, if you're not a big fan of playing this kind of crate pushing games, then yeah, just be aware of it, that you can also automate this one. But I think it's pretty fun and it's not that difficult. So that's not the main part of the whole challenge. And when you reach the level here, The factory is going to be powered down, and you can see that the achievement is unlocked here. The smart gnome face is now lit up with these green LEDs, and you can talk to Chris to get the achievement and solve the challenge basically. So let me just see. Now we have Hack-a-Gnome solved. Okay, I have to do this quickly for the other account because that's actually not the account that I use for the recordings. It was just easier to kind of show the different approaches here. And that's it. So I know it was extremely long, but it's a cool challenge. And like I said, I don't really feel that this is really the 3 out of 5 snowflake type of challenge, but it was certainly a fun one. You will see that the rest of the challenges are significantly easier, especially if you're not really considering the coding part. Now, even though I was not going through the entirety of those scripts, I'm going to share them in the comments. I just need to set up the paste bin pastes, just like in last year's case. And you can download the script and try it yourself if you like. But I try to keep it short for the coding part for the challenges. I'm not going to go through the entirety of the scripts because, well, I didn't write the scripts, and I think you should not write the scripts either. But we'll see with the last 2 challenges before we unlock the grand finale challenge. And you will see what I mean because it's way faster. And to have an LLM tool write these. And this is essentially a CDF game. So when you play it the first time and you compete on the scoreboard, your goal should be to score points as fast as possible, not like sit and try to figure out why your Python program doesn't work just to see that there's something that was not correctly indented. So that's it for this challenge. And the next one is going to be still a challenging one, but significantly shorter and easier than this. So come with me and check out the next challenge in the next video.